Hello. Yeah. Zankana, you are able to hear?
Yeah, sir.
Yeah, yeah. Okay. So I think there was some.
Yes, sir, I can hear
Yeah.
you.
Great. So let's start this second session. We were talking about the data in the morning hours, correct? And we will do some examples here. So these are some numbers. Okay. By looking at these numbers, what do you what information do you get? Very little information, right? Now, if we give some more information like number of forms received per hour is 347. So we get more information as to, what is the rate of forms every hour what we are getting. So from this data, can we find out what is the average number of forms per hour? Have you calculated? स्मिता आपको कैलकुलेट कर सकते हैं? हेलो स्मिता, are you able to hear?
Yes, sir.
Yeah. So can you calculate the average?
Uh, when we will, if we have variable data,
Hmm.
so if on to the correct point, midpoint,
Hmm.
so we are applying average.
Hmm. So how do you calculate the average?
Uh, sir, there is a formula for average calculation
Yeah.
is equal to
Hmm.
average sum or in bracket
Hmm.
uh, select all the rows and then drop तो ऑटोमेटिक आंसर आ जाता है.
That is in the Excel you are saying, right?
नो सर.
Have you opened your Excel?
यस सर.
Have you opened the Excel?
नो सर.
Yeah. So if you put this in Excel, you
हाँ.
can get the average, correct? There are formulas also, automatically it calculates, but manually how you will calculate the average?
मैन्युअली एडिंग एडिशन ऑफ ऑल
Yeah.
नंबर्स.
So what is the addition of all these numbers? How many forms on that day were received? Total number of forms received. What is the total? जंगना आपको कितना टोटल आया है?
एक मिनट है सर.
हाँ.
सर 1 सेकंड कैलकुलेटिंग.
हम्म. थोड़ा लंच के बाद में थोड़ा एक्सरसाइज करना है ना. विल गो टू स्लीप. What is the total?
So total is 45 for this
Yeah,
number of forms received column
right. And
and average is 5.6.
5.6.
Yes,
Okay.
so 5.25 it's average.
Yeah. So 5.6 forms per hour, isn't it?
Yes, sir.
So what we are getting is the statistic, that is average based on this data is 5.5 forms
Hmm.
per hour. Hmm?
Yes, sir.
So then you can set a target that, on an average, my target is 10 forms per hour. But what
Hmm.
you are getting is only 5.5 forms per hour. Okay, na? So this helps us in, understanding that, we need to increase our average. Second is what is the variation? Range. What is the range?
Acceptance quality area.
The range means maximum minus minimum is called range. So here what is maximum?
Acceptance quality area.
No, maximum is 9 hours per
Range.
day.
9.
9 forms per hour is the maximum number of forms, right? And minimum is
3.
2 forms.
2.
2
2.
forms per hour. So therefore range is 7.
7.
7, so this
7.
7 is the range. So this also gives us some information that, there is a large variation in number of forms received, among the hours, different hours of the day, right? Now, similarly, if you want to understand, I am giving some more information about this. So this table now gives the number of rate per hour, every hour how many forms we are getting on day 1 of the month and on the last day of the month. So last day of the month, what is the total? I am getting 77 is the total divided by 8. So something like 9.6 is the average, correct? So what is the information we are getting from this analysis? The range on last day is 20 minus 6, which is 14. So range on the last day. And average on the last day is 9.6 forms. Average on first day is 5.6, 5.5 forms. Okay. So does this give us some information? How you will interpret this information? If you are the in charge, for a branch, and these are the number of application forms, account opening form, for example, a trading account opening forms are coming. So as a branch manager, how it helps you? जनका ना आप बताइए इंटरप्रिटेशन इसका.
Sir, so range will be like, 20 minus 3.
For the last day, the range is 20 minus 6. Individually we are talking about.
For the last day, okay.
Yeah.
Then it will be 20 minus 6
Hmm.
and for last day. And for first day, it will be 9 minus 3.
9 minus 2.
2.
9
2
minus,
is the lowest.
yeah, so 7, right?
Hmm.
And average is 5.5 for the first day.
I am just calculating that, sir. Actually, इसीलिए 1 second, sir.
Hmm.
Mm. That's true. 45 is the total value divided by 1, 2, 3, 4, 5, 6, 7, 8. Divided by 8, so 5.6 for first day ka column. And 7 plus 8 plus 10 plus 12 plus 6 plus 9 plus 15 plus 20. So total is 87 divided by 3,
Oh.
7, 8.
Mm-hmm.
So 10.87.
Oh, 10.87 is it?
Hmm.
Okay. Smita, you are getting the same answer? Hello?
Yes, sir. Yes, sir.
Same
10.88.
answer. 10.887,
Yes,
correct?
sir.
So, can you comment on this now? If you have to, comment on this data, how you will comment in 2, 3 lines?
Uh, there is more data required to calculate all these are, but mostly I did that work in Excel, so it is easy to use by formula because
Yeah, no, that is fine. You have calculated the averages, ranges, and all. But as a manager, you want to interpret this data. So, how you will interpret this data? So, for example, I will say that the average on first day is far lower than average on the last day. That means there is a rush on the last day of the month, isn't it? So, people are working hard towards the end of the month compared to beginning of the month.
yes, yes, sir.
That is what my interpretation will be. So what I, as a manager, I have to motivate them, work hard from the beginning. Every day, have a good performance. You can achieve 10.87 forms per hour rate on the last day. So why can't you achieve it right from the day one so that your performance improves, isn't it? So this is what, as manager, I get information. And then I, take suitable decisions and I drive my team, correct? Then there is a range can help us, hourly there is a difference. So if we can do something about increasing, the rate during the hours, then it will improve the performance. So more data helps us in understanding what is the, performance. So if I want to know what is the average for the month, based on these 2 days, I will not be able to calculate the average because I know there is a, huge variation in the performance on day one and last day, and in between I do not know what has happened. So therefore, based on this limited data, if I give the average, then it will be misleading. So I need sample from every day, then it will give me the correct estimate of the average and range, isn't it?
Every single day, it is necessary to input your all the
Yeah,
correct information.
right.
We,
So there
done
is a so there is a variation in day-to-day performance. So therefore, we have to take sample from every day and not rely on the sample from first day and last day, isn't it? Otherwise, it will be a misleading representation of the population. Clear?
Yes, sir.
Okay. So basic characteristics of number.
Screen is not visible.
Screen is not visible, is it?
Yeah, sir.
जंकाना आपको दिख रही नहीं?
मेरे को दिख रहा है, अभी
ओह
नहीं दिख रहा है।
नहीं, अभी मैंने बंद किया. अभी
हाँ,
आई एम
उसके
शेयरिंग.
पहले दिख रहा था सर।
अभी मैं फिर से शेयर कर रहा हूँ. अभी दिख रहा है?
नहीं,
अभी
हाँ
आया
अभी दिख रहा है।
या-
डबल क्लिक करना पड़ेगा सर, आप
हाँ
डबल
नहीं,
क्लिक का कमांड दे रहे हो।
हाँ नहीं दिखा ना आपको अभी?
हाँ अभी दिख रहा है।
हाँ और
नहीं, इसके पहले
इधर
ना
नहीं आ रहा है।
हाँ हाँ
आपको डबल क्लिक करना है, वो स्क्रीन पे
हाँ
लिखा है डबल क्लिक टू व्यू द स्क्रीन।
हाँ प्रवीण, आप डबल क्लिक करिए स्क्रीन के ऊपर.
सर आई एम नॉट
इट मे बी
डबल क्लिक
बिकॉज
कर रहा हूँ बट
इट मे बी बिकॉज योर नेटवर्क में भी है प्रॉब्लम. और आप फिर से लॉग इन कर लीजिए, because all others,
ओके ओके फाइन।
yeah, all the others they are able to see, right?
हाँ एक बार लॉग आउट कर
ओके
देख।
सर।
कभी मुझे आधे तक क्लास में सर।
हाँ तो प्रवीण, आप रीलॉग इन कर रहे हो क्या, या दिख रहा है आपको अभी डेटा दिख रहा है, स्क्रीन? Refer to page number 4-3. स्मिता देखा आपने पेज नंबर 4-3 इन द बुक? फोर डैश थ्री 3.1 क्या दिया हुआ है, पढ़ेंगे? कैन यू रीड दैट?
Three, sir,
3.1, या
there is measure measures of location for a set of observations, mean or arithmetic mean.
okay, so we were talking about mean or arithmetic mean, and we calculated that mean and arithmetic mean for this data, and the formula is given here: x bar equal to 1 upon n and
Yes,
summation of the individual values, correct?
yes, sir.
So this is the way we found out the mean or arithmetic mean, or what we call as average, correct?
Yes, sir.
Now there is another measure of central tendency, and that is called mode. So please read what is the meaning of mode.
Mode is the value that occurs most often in a set of data. For example, model color of rose is red. In the above cricket score example, made is 29 runs as it occurred twice.
Correct, correct. So if we have to find out mode in this data, first day and second day combined, suppose we combine the data for day 1 and day 2, so how you will find the mode?
Uh,
You will have to
Average is it's we can calculate by filter also, some formulas also.
yeah, that is formula, but to understand manually, what generally we do is we arrange it in the increasing or decreasing order. Increasing order we arrange them, correct?
Yes, sir.
So we will be able to find out which is the number which has occurred maximum number of times.
Yes, sir.
Okay. So in the book, what example has been given, that illustrative example, 24, 29, 25, 30, 29, and 31. So once we arrange it in increasing order, now we find that 29 is appearing twice. All other numbers are occurring only one time. So as per the definition, mode is the value that occurs most often in the set of data. So therefore, the mode there was 29. Okay.
Hmm.
And next is the median. That is another important measure of central tendency.
Median.
Yeah. So
Uh,
yeah, what is median?
Median is the value for the which 50% observation lie on either side of it. Arranging the cricket score in ascending order, we have the data set as since it is set of even numbers,
Yeah, it
they
is, no, read that 24, 25, 29, 29, 30, 31, right? So by arranging, one is mode we have identified as 29, which has occurred maximum time number of times. Then median is the middle value in the data, isn't it?
median values of data, sir, it is as same process like average, na?
No, in average, you add and divide by n. Here, you are arranging in ascending order. So, and finding out what is the middle value. So here, how many data points are there? 1,
6.
2, 3, 4, 5, 6,
Yes,
right? So
yes,
the middle one is third and fourth is the middle ones, 29, 29 and 29. So what
sure.
we do is we take an average of these two values, 29 plus 29 by 2 is 29. So therefore the median is
29.
29. Okay. And measure of spread, as we said, range and standard deviation. So let's find out the standard deviation for this data set. Are you able to see the PPT here? The screen, you are able to see the data?
Yes, sir.
Okay. So let's find out the mean for this data, which is 2, 4, 6, 1, 3, 6, 6, 4. So what we have done for finding out the average or mean, 2 plus 4 plus 6 plus 1 plus 3 plus so and so. So which is 32 divided by number of data points 8. So the mean is 4. Correct?
Yes.
Now for this data set, can you find out the mode? Everyone, what is the mode?
6.
Right. Why? Because why 6 is
Repetition of
the
the
mode?
number 6.
Yeah, Praveen. Why 6 is the mode?
So repetition number 3 times repeat 6.
So
Right.
highest number of repetitions are there.
Yeah.
Is occurs highest number of times in the data set. So therefore, 6 is the mode. Now find out the median. So you have to arrange it in ascending order. So 1, then 2, then 3, then 4, then 4, then 6, then 6, then 6, isn't it? So 1, 2, 3, 4, 5, 6, 7, 8 data points are there. And if you have to find median, what we will have to do? The two middle values.
Plus 6.
4
Yeah.
and 6.
Which are the two middle values?
4 and 6.
4 and 4,
6.
no?
4 and 4.
Yeah, 4 and 4. So average of 4 and 4 is 4.
4.
Or the median is 4, right?
Yes, sir.
Mean is 4, mode is 6, and median is 4, right? So these are the three different, measures of central tendency. How does it help us? इसमें फर्क क्या है मीन मोड और मीडियन में?
So, main mode में we can collect the multiple variable data and we calculate the average. And in median, if repetitive numbers if occur, so we calculate that average.
Right. So mode will give us, which number is occurring highest number of times. That is what information will be coming here. So in certain situations, that will be useful way to, understand the population. Where is the mode, right? And median will help us in understanding the spread of the population. Where is the 50% population, below 50% and above 50% it gives. And if you look at that, the median, tells us that 50% of the population is below that point. So for example, population of India, the average population, average age, if you calculate the average age of Indian population, it might come to say 40 years. Okay, average age of Indians. So you calculate it by age of the infants to age of the eldest person, correct? So you get the average age as 40. Now, in Japan, if you try to find out the average age, you will find it is 50 years. Okay, so what does that mean? The average age is 50 years. So does it, what is the difference between Indian population and, Japanese population? What type of, information you get? Can you interpret? When I am saying average age of Indians is 40 years and average age of Japanese is 50 years. I'm not talking about the life expectancy. I'm talking about the average age. तो ये दो चीजें आपको बताई, तो आप इससे क्या इन्फ्लुएंस डिराइव करेंगे? कुछ आइडिया आता है इससे? ना प्रवीण, कुछ आइडिया मिलता है उससे? एवरेज एज ऑफ इंडियंस इज 40 एंड एवरेज एज इन इंडिया, नॉट इंडियन, एवरेज एज ऑफ पर्सन्स इन इंडिया इज 40, एवरेज एज ऑफ पर्सन्स इन जापान इज 50. तो
आइडिया तो यही है इसमें कि जब पॉपुलेशन कम होने के कारण वहां पे एवरेज ज्यादा है जापान में।
या वो तो मतलब गलत हो सकता है इंटरप्रिटेशन उसमें, कि भूटान की पॉपुलेशन और भी कम है, ठीक है, और वहाँ की जो एज है, और यू कैन टेक एनी दिस अफ्रीकन कंट्री स्मॉल वन, उसकी पॉपुलेशन कम है और
हम्म।
उसकी एवरेज एज भी कम है। तो वो इंटरप्रिटेशन आपका रॉन्ग भी हो सकता है, योर प्रिमाइस, योर हाइपोथेसिस कि पॉपुलेशन कम होने से एवरेज एज बढ़ती है, दैट पॉपुले हाइपोथेसिस नॉट करेक्ट, नो, क्योंकि इन केस ऑफ
ओके सर।
अफ्रीकन कंट्रीज दैट इज नॉट द केस, सो दैट इंटरप्रिटेशन इज रॉन्ग, इट इज नॉट यूनिवर्सल। जंकाना, आप बताइए।
इसमें सर
या देखिए, यू विल हैव टू गो टू द बेसिक्स कि आप कैसे कैलकुलेट करते हो एवरेज, तब आपको समझ में आएगा, देन यू विल बी एबल टू इंटरप्रेट। व्हाट हम क्या करते हैं कि सबकी एज जो है उसको ऐड करते हैं, है ना, और फिर
जी
नंबर ऑफ पीपुल से
एवरेज
डिवाइड करते हैं, तो इसका मतलब
एवरेज
यहाँ पे एवरेज एज कम है, इसका मतलब वहां पे यंग लोग ज्यादा है ना।
राइट सर।
और जहाँ पे एवरेज एज ज्यादा है वहां पे ओल्ड पॉपुलेशन ज्यादा है, दैट इज वाई द एवरेज एज इज हायर इन जापान, isn't it? So the interpretation is that in a country, if number of people are older people are more, then you will have the average age higher. ठीक है? So this is one interpretation helps us in understanding that particular population. Second is mode. Suppose कि इंडिया में मोड आता है, 47 years, जापान में मोड आता है 42 years। तो क्या इंटरप्रिटेशन है कि हम इंडिया में बहुत सारे लोग ऐसे हैं, मैक्सिमम लोग जो है वो 47 years वाले हैं। आई एम गिविंग ए हाइपोथेटिकल सिचुएशन, एग्जैक्ट डेटा नहीं है मेरे पास, बट इट हेल्प्स अस इन फाइंडिंग आउट विच वैल्यू इज ऑकरिंग हाईएस्ट, सो 47 year वाले सबसे ज़्यादा है। फिर दूसरा, अब इफ यू लुक एट इट में कम आउट दैट 27 years वाले ज़्यादा है। अब क्यों, क्या रीज़न है, हमको पता करना पड़ेगा कि वाई इट इज़ हायर। थर्ड मेजर इज मीडियन, तो इंडिया का मीडियन है ना 35 years है। मीडियन वैल्यू फॉर इंडिया इज 35, द मीडियन वैल्यू फॉर जापान इज 55। तो व्हाट इंफॉर्मेशन डू यू गेट? वेरी इंपॉर्टेंट मेजर, मीडियन। मोदी जी बोलते हैं ना कि हमारा देश जो है ना, वी आर द यंगेस्ट नेशन, right? So why he is saying? Because 50% of the population is below 35 years of age. isn't it? So this is how, these measures of central tendency help us in understanding the population. So we did this mode, then we did median. Now the range in this data, the range is 6 minus 1, that is 5. That's a statistic, a fact or piece of data obtained from a study of a large quantity of numerical data. So what you get is the statistic. In this case, the range is the statistic, which is 5. Now, another statistic is standard deviation. So this is the formula for calculating the standard deviation of a population. So left-hand side is given for the population. If you include all the population, all the data points, then you can use the left-hand side formula. If you are taking a sample, then you have to use the right-hand side formula. Yeah, this we have seen in the morning also, standard deviation. Okay. Now, can you calculate the standard deviation? Sample standard deviation. Please calculate the sample standard deviation. ये formula आप लिख लो, and then the data is here. 2, 4, 6, 4, 1, 3, 6, 6, 4. कैसे करेंगे? जंकाना आप एक्सप्लेन कर दो एक बार कैसे करना है इसको. हाउ डू फाइंड द स्टैंडर्ड डेविएशन देन इन.
सो सर आप
या
नेक्स्ट स्लाइड पे जाइए ना,
हाँ
वो स्टैंडर्ड
ओके
डेविएशन
हाँ
का.
या
So standard deviation, you have to calculate for sample and population. Generally, when you are doing it for sample, then you take each and every value for that particular parameter that, or the value that you've taken, say 10 values are there, you will calculate standard deviation for each value. And that is xi minus x bar. X bar is average, and you will, xi is that particular value. So if your average is 5 and your value is 10, 10 minus 5 whole square, that you will calculate. 10 minus 5, you will calculate like that for each value. Now, you will, the E that you see, that is summation. So you sum that, divided by N is the total number of samples. So if total samples are 8, 8 minus 1, and that becomes your, and you put it in the formula, that becomes your total standard deviation for that particular sample. For the entire population, the denomination is sigma, and mu is considered as the population average, where over here in the sample you will use x bar. Over here it is mu. And you will put, again calculate for each value. And then you will put the total population as n. Over here, n minus 1 is there. This is to cancel the factor of any biasness which is there in the sample as compared to the population. And
okay, so
then
fine. So you understood how to calculate. So calculate for the sample. Use the right hand formula. Find out the standard deviation for this data. So what is the average? You need the average, no? In that formula, there is xi minus x bar. That means you need the x bar. So x bar कितना है इसमें? Add all these values. 2 plus 4 plus 6. That is 6 plus 6, 12 plus 4, 16 plus 1, 17 plus 3, 20 plus 6, 26, plus 6, 32, plus 4, 36. So 36 divided by how many values are there? 2, 2, 4, 2, 4. 9, isn't it? There are 9 points. So what is the average? 36 by 9 equal to 4. So आपको x bar is 4 and n is 9. Now you can, with x bar 4, n 9, can you calculate the standard deviation? The formula is given here. Sigma xi minus x bar whole square divided by n minus 1. So you know x bar, you know n, and xi values are given here. So can you calculate the standard deviation? Five minutes. 5 minutes for doing this. Everyone has to do this. Find out the standard deviation. In case of any difficulty, you can ask me. Okay, so 5 minutes are over. I hope all of you have been able to calculate the standard deviation. Yes, who has completed? Can you tell what is the value of standard deviation you are getting? स्मिता, आपका हो गया कैलकुलेशन? Jankana, how far have you come?
I have done it.
What, what is the
Standard deviation is 1.802.
802? Okay, good. And स्मिता, आपको क्या मिला? प्रवीण, आपको you have been able to do? Smita, how far you have reached? So this is the answer. Jankana, you got the right answer. 1.802. So I think those who are not done, please complete this exercise. You will get questions in examination like this, and there, uh, if you don't have practice, you will find it very difficult, and it will be very, very time consuming for you to get the answer. So therefore, do these exercises. There are a number of exercises which are given in the book. Can you open page number 4.3? It is already open, right? So mean, mode, median, and then we have quartiles, and we have other things like harmonic mean, geometric mean, which we don't use very much. So we will go to measures of dispersion and variability, which are explained here. So as I said, the standard deviation, and there are number of methods of calculating the standard deviation. This was a very simple example, which we took. But if there is a large number of data, then there are methods which are given, but just read through them. You need not be expert in doing all these things, as nowadays we have the softwares available where you just feed in the data and you get the answers of the standard deviation. Earlier days we had to do it manually, and you can see how tedious it was. There are number of examples worked over here in next till 4.11 and all, and it used to be so tedious. But nowadays the softwares like Minitab or even Excel has a lot of capability to do these calculations. So you need not.
So, sir, in Excel, now we can do STDEV
Right,
and select the range, that
correct,
is the total samples.
right,
Just scroll it through that and close the
right,
bracket, and you will get 1.80.
right. So the another software which is there, that blue sky statistics, which is a free software which everyone of you should download. The blue sky statistics. Smita,
Yes, sir.
you write down blue sky statistics.
Yes, sir.
Download it in that software application from your internet, and use it for analyzing the data. Okay.
Sir, blue. Sorry,
Blue,
again, repeat again.
blue sky statistics.
Blue sky.
हाँ, ब्लू स्काई स्टैटिस्टिक्स है ना। आप इंटरनेट पे जाओगे तो उनका साइट ओपन होगा एंड यू कैन डाउनलोड दिस फ्री सॉफ्टवेयर which has very useful features for statistical process control, even for Six Sigma.
Yes, sir.
Okay.
Okay, sir.
Uh,
Minitab is very costly.
Minitab, is very costly. License fee is around, I think, 1.5 to 2 lakh per year.
Yeah,
You
it's
know,
more now.
okay. So we don't need in day-to-day application. No, we don't need the Minitab. Large companies which exclusively work on Six Sigma projects, then they acquire the licenses for their people. But otherwise, it is not required. You can use the Blue Sky Statistics free software for most of the analysis which you will come across. Okay. So try using that, download that software, and maybe we will explain you a bit on that. But first you need to download that on your computers so that you can get some hands off. So maybe next time when we meet on 11th, that time I will explain how to use that Blue Sky Statistics software. Okay. Now, this is quartiles is another important tool to understand the variation in the population. So quartiles are used. Now the example is taken from the book only. Suppose scores of 6 randomly selected T20 games of a cricketer, player A, are like this. So he has a score 24, 29, 25, 30, 29 and 3 runs. 31 runs, not 3 runs, 31 runs. So the data, when it is organized in ascending order, it looks like 24, 25, 29, 29, 30, 31. Correct? So what we want to understand is uh, what proportion of the population is below, is up to 25%. The first quartile we call Q1 is a value below which 25% of the observations lie. Now I gave you an example of median, and I said in India, 50% of the population is below 35 years of age, you know. So that is the second quartile, which is called Q2. Q2 is a value below which 50% of the observations lie. So in India, below 35 years of age, 50% of the population lies. Correct? So that's why India is the youngest nation in the world. So median value is what defines the younger, which nation is younger. So if you go to Japan, the median may be 55. In Europe, the median may be 45. So that means below 45 years of age, 50% population is there, and above 45 years of age, 50% population is there. Correct? So that's all. So therefore, the working population is, if you want to find out, then the working population is from say 20 years of age to 40 years of age. We can find out what is the proportion of population between 20 years and 40 years. So this is the way, you analyze the data and get useful information. And the government, is using this type of statistics to plan the, economic activities. Now Q3 is the value below which 75% of the observations lie. And the formula is given here for Q1, Q2, Q3. If there are n number of data points in the data set, so the formula is n by 4 plus 1 by 2 is the first quartile Q1. 2n by 4 plus 1 by 2 is the second Q2, and 3n by 4 plus 1 by 2 is the Q3. So in the data here, you see, you can find out the last column is giving what is Q1. 6 by 4 plus 1 by 2, that is 2. Understood? This is, this is taken from the book only. So you have this example in the book. We'll go to the next slide, understanding the frequency distribution. Right? So we saw, the mode is the one where maximum number of observations are there. Correct? But if you want to understand the complete data, we want to understand, what is the type of variation within the data. So this is the example taken from Coca-Cola bottling plant of Najibabad on data on gas volume. So gas volume in the 300 ml soft drink is there, 300 ml soft drink. So per bottle, the gas volume is given here. Specification is it should be 4.10 plus minus 0.25. Sample of 100 bottles are collected for the period October to December 05. Okay. So this is a data collection format which should be very specific, that the company name is given, what is the data we are talking about. We are talking about data on the gas volume. The product is given, specifications are 4.10 plus minus 0.25, and sample size is 100, and the period is also given. So based on this data, we can do a frequency distribution analysis, and the exercise is like this. Put tally marks, find frequency distributions, and draw a neat histogram. So 2-3 things have been asked. So frequency diagram has to be done and histogram has to be done. Comment on the distribution pattern, draw specification limits and estimate percentage of undercarbonated and overcarbonated bottles, compute average, standard deviation, and coefficient of variation. These are the 4 things which have to be done. Now you see how it is done. So the complete data, the highest and lowest points are observed. So gas volume in this data, you find out what is the lowest. If you trace it among this data, you will find 3.8 is the lowest gas volume and 4.4 is the highest gas volume, So against each gas volume, what is the frequency? 3.8, 3.9, 4, 4.1, 4.2, 4.3, 4.4. So against each, 3.8, there are 2 bottles which had 3.8, as the gas volume. Then there were 9 bottles which had 3.9. There were 19 bottles which had 4. There were 37 bottles which had 4.1. There are 21 bottles which had 4.2, 11 bottles which have 4.3, and 1 bottle which has 4.4. So looking at the pictorial view, what can we comment? What is the central tendency? Without calculating average, what is the central tendency? What do you think is the mean of this around approximately? Yes, प्रवीण, इस डेटा से आपको सेंट्रल टेंडेंसी के बारे में कुछ आइडिया आता है?
4.1.
Yeah, 4.1, right? So looks
Yes.
like the process is centered at 4.1. Most of the bottles are having gas volume 4.1 plus minus 1 probably, you know. So most of the bottles are coming in that range. Then there are very few which are at the lower side, 3.8 and 4.4, isn't it? So frequency distribution helps us in understanding the pattern of variation. Okay, this example is also taken from the book. Then we have the histogram. So the same frequency distribution, what we saw here, now it is converted into a bar chart. So when you convert the frequency diagram into a bar chart, it becomes a histogram. There is a separate chapter on histogram, you know, how to construct the histogram and all. So you can, you know, with this example, you know, it's very easy. So you find out the, you know, value that is 3.8, 3.9, etc. But, you know, if you have a lot of bottles and the values are up to 2 decimals, you know, then what you will find that you will not be able to take each point like 3.8, 3.81, 3.82, 3.83 like that, you know. So there are probably, you know, 10 points between 3.8 and 3.9. So what you will take a range there. Your first range will be 3.8 to 3.9. So whatever data points are falling between 3.8 and 3.9 will be coming under the first category, first bin we call bins. So number of bins there will be, and we take usually 8 to 9, you know, 7 to 10 bins we divide the data into, and then find out under each bin how many data points are there, and then in proportion to the number of data points in that bin, we draw a histogram, which gives us a similar indication of pattern of variation. Like it is, you know, central tendency is around 4.1 and the spread is from 3.8 to 4.4. It resembles the normal distribution. So we can find out standard deviation, we can find out average, we can find out plus minus 3 sigma, and we can find out whether the plus minus 3 sigma is within the specification. Okay. So this thing is worked out here, which is given computation of average and standard deviation. The average gas volume, when you do the average of those 100 data points, it come to 4.103. You need not do it right now, but you know, just for your understanding, you can do it later on as a practice. This implies that the process is centered. Your specification is 4.10 and average is 4.103. So it means it is centered correctly. The process is accurate. Central, you know, the setting is correct. Now, variance in the gas volume, that the sigma is coming to the same formula in different form, and the standard deviation works out to be 0.0147. Therefore, the standard deviation variance is 0.0147. So standard deviation is under root of that, which is 0.1212. Now, sigma n is the estimate of population standard deviation when the divisor is equal to sample size and sigma n minus 1. This we have seen. Sigma n minus 1 is generally denoted by sample standard deviation. If the sample size is small than 30, always use S, that is the n minus 1 formula. If it is more than 30, then use the formula for sigma, that is divided by n. These are the guidelines for calculating standard deviation. Now, coefficient of variation is another term which is given here. You know, standard deviation divided by the average is what the meaning of coefficient of variation is. So, for example, in this previous example, coefficient of variation is sigma is 0.1212 divided by x bar, that is 4.103. And in terms of percentage, it comes to 2.95%. Correct? So, what is the meaning of that? That the variation standard 2.95% of the population is beyond a particular percentage. So say this is 3% variation, 2.95. It is defined as standard deviation divided by mean, and the note that divided. CV is useful. The standard deviation data must always be understood in the context of average value. CV of 2.95% means the standard deviation is equal to 3% of the average. Okay. So, you can say that the standard deviation is 3% of the average. And you can develop for your particular process what should be the acceptable value of this percentage. So coefficient of variation helps you in deciding that what should be the standard deviation compared to the average. And that particular thing over a period of time, you can try to sort of improve upon. That means, the variation you want to reduce. Currently, it is 3% of the average. Now you can set the next target to 2% of the average, or not 1% of the average. This can be used when all the values are positive. In case the values are negatives, which is not happening generally in the industry. So in case the excess are negative, then this formula does not work. So therefore, you have to be careful. If the values are coming in negative, for example, the temperature, if the parameter is temperature and it goes into negative also, that time this formula may not work. Okay. So now the what is the time? It is 3:23. Okay. At 3:30 we will go for the break at 3:30. Let's complete some more things. This is not relevant. This use of software, which I will cover next time when we meet, the blue sky statistic which I was talking about. So there are a lot of things which we will cover, Okay. Box plots is another thing. Now you see we understood that quartiles, So using that concept Q1, Q2, Q3, you can plot a box plot, right? So box plot is a method for demonstrating graphically the locality, spread and skewness of groups of numerical data through their quartiles. In addition to the box on a box plot, there can be lines which are called whiskers extending from the box indicating variability outside the upper and lower quartiles. Okay. The plot is also called the box plot and whisker plot and the box and whisker diagram. Outliers that differ significantly from the rest of the data set may be plotted as individual points beyond the whiskers on the box plot. So, we have seen that Q1, Q2, Q3, and as we said, 50% is Q2, and for understanding, 50% of the population is below Q2, that is 35 years of age, is 50%. And we would also like to know what population, 25% of the population, what is the age? So we might come to, based on the data, we might find that the Q1 comes to 20 years. That means 25% of the population is below 20 years. Okay, so that's the use. So 20%, 20 years, 25% population, below 35 years, 50% population. Then Q3, 75% population is 50 years. Below 50 years, 75% population. That indicates to us that 25% of the population is above 75 years. 75% of 25% of the population, the age is say 60 years. So 60 years के ऊपर जितनी population है, it constitutes only 25%. In case of Japan, this uh, this Q3 may be about 70%. So a lot of population is beyond that particular age. So that way, this diagram helps us by plotting that Q1, Q2, Q3 on a box type of diagram, and Q1 to Q2 is first box, Q2 to Q3 second box, and beyond that, these 2 points beyond Q3 and below Q1 are called whiskers. So if you take an example of actual manufacturing data, you might find that most of them are between Q1 and Q2, and there are very few which are beyond Q3 or below Q1, and those probably we call outliers, and the specification limits might coincide with Q1 and Q3. Okay, but anything beyond Q3 and below Q1 are outliers, and they may not be because of the inherent variation in the process. It may be because of some special cause of variation. So the box plot helps us in understanding the pattern of variation, like frequency diagram or histogram. Only thing, when we use box plot when the number of data points is less than 30. If number of data points is more than 30, then we use histogram or frequency distribution chart. Okay. Now, these are various examples of histogram and corresponding box plot. So histogram is giving us this type of distribution pattern, where the box plot is giving us this. So it indicates it's a skewed population, towards the left side. The histogram is skewed towards the left side, and very few points are beyond 20. So that is what is indicated in the box plot. If you had less number of data, the box plot will give you this picture that there are very few points which are beyond 20. The whisker is telling us most of the points are in the Q1, Q2 and Q3 range. Right? This is too much skewed towards left. So, here you are finding that even beyond 10, there are very few points. So these are, various data representation tools, and they may be useful and understanding the pattern of variation and taking the decision. So when you use it on actual data, your process data, you will be able to derive a lot of meaning out of that. Okay. So that's all about the this session, and we will take a break for 15 minutes, and we'll be back by say 3:45. Okay. So rest of the topics, we will try to cover in the last session, 3:45. So we will try to, we'll close it by 5 o'clock, because, some of you were attending the session yesterday also, and today also you are there. So I don't want to put you under a lot of strain, but just introduce you to the subject briefly so that you develop an interest, and then, get into the in-depth study of the subjects. Okay. So let's break for, tea, 15 minutes. 3:45 will be back.